Thanks to the research office, Jason, and the selection committee for deciding to give me this award. Really appreciate it. And thanks to all of you for coming out on this rainy day. It's not a day for travel, but thank you for showing up for this talk. Thank you. And also my colleagues in the Department of Economics, my academic home, and especially Sahan Dissanayake, who kindly nominated me for this award and did all the paperwork that Jason mentioned. I didn't have to do any of it. So, students, a number of students here, my students here, and former students who've gone on to great things as well. So thank you for students that always inspire me. Thank you for coming. None of my work over the years basically is alone. Just very few of these papers are alone. A lot of collaborators around the world in just like 20-some countries. So thanks to them as well. And a lot of funding powers this research, including from Portland State, but also especially from the World Bank and the Environment for Development Initiative that Jason mentioned. Okay. So next, after the thanks and acknowledgements, let's state the obvious. Forests are just amazing, aren't they? And forests have always caught my interest, and I just love forests. They're great. Next slide. From an economic perspective, what makes them amazing, one of the things is that all the ecosystem services that they provide, like carbon sequestration. And this is a paper, like all of them, co-authored, looking at the value of the carbon sequestered in U.S. forests, in all the forests in the U.S. And it offsets something like 10% of our emissions every single year. Also, habitat and biodiversity. This is a recent review that came out last year by Partha Dasgupta, looking at the economics of biodiversity. In there, Partha emphasizes the critical role of forests, especially tropical forests, which we think of our forests here as being enormously productive and amazing, and they are. But tropical forests are way more productive. And so that's where the action is. But also extractive products like fuel wood and timber, the forests give that, and I'll be talking more about that. It just goes on and on when you think about forests. Oxygen production, air pollution filtration, recreation, health, sacred spaces. These from an economic perspective, we would think of these as services to humans. Water filtration, and just on, right? Forests do enormous things for people. And so what I'm going to focus, this is a big topic, and so I'm going to carve out a smaller piece of this. And I'd like to focus on forests, carbon sequestration, some of that fuel that I mentioned, and a bit of biodiversity in two countries that I would like to suggest are somehow emblematic of a lot of the world, what Professor Paul Collier at Oxford University calls the bottom billion, the poorest billion people. So first, one thing that always amazes me is how kind of rare in the world landscape forests are. Of course, we have them here, and so we think they're everywhere, but it's not true. The Western U.S., of course, Canada has one of the biggest stocks of forests in the world, Eastern U.S., and in Europe and across Russia and the northern part of Europe and Asia. And then in Latin America, of course, this being the Amazon basin, where the home of ground zero of biodiversity in the world, and then Africa. But a lot of the world doesn't have forests, and some in Southeast Asia as well. And so a lot of this forest is in the lower and middle income countries. I think that's a point I definitely want to make. And virtually all the loss, like what the World Wildlife Fund calls the hotspot areas, notice how many of those the red dots are in the so-called lower income world. Much of the North has been adding forests for many decades. Interestingly, China, over to the right, you see there's green. There's some hot spots there too, but on aggregate, China's been adding forests for 20 years. China actually adds the most forests of any country in the world in terms of, and not as a percentage, but in terms of area. So here's the losses in terms of area. So you see Brazil is a real issue. Sub-Saharan Africa, there you see China bright green because they've added so much forest. India, also another country that has added a lot of forest area. And then down in Indonesia, another kind of a place where a lot of area of forest is being lost. Now, the third point that I'd like to make here is that biomass cooking is important in this. A lot of the world's population does not have access to clean cooking. And actually, like 60% of the world regularly cook with fuel wood on a daily basis. It's a very common thing. Like 40% of the world, people are making campfires in their kitchens to cook on a daily basis. And you see, there's the numbers in millions. So, in 2015, about 2.8 billion people were cooking with wood on a daily basis. And that's really not expected to change that much. It's expected to change in terms of percentages. The percentage is falling, but the actual millions of people, that's going to stay fairly constant. The biomass cooking is important there as well. It's actually more than transport in the world stage in terms of emissions and contribution to climate change. And also importantly, biomass cooking and just fires releases what's called black carbon. It's sort of the opposite of an aerosol, and it's a very dark particle that is very light, floats in the atmosphere for a few weeks, and while it's there, it really soaks up the infrared radiation and re-radiates it as heat. So probably black carbon is the second most important climate forcer, second to, of course, CO2. Next slide. And then, of course, we don't want to forget the human element. I'm going to have something to say about that as well. To get these fires going, you have to collect the wood, you have to chop it up, and that's a big labor burden. That's a big labor burden, especially for women and children. Yeah, thanks. And again, and then you're making this campfire in your kitchen, and that just creates an enormous amount of smoke, and releases a lot of toxic materials that people are breathing in, particulates. Benzene, nitrogen oxides, all sorts of hazardous chemicals, and the concentrations in those kitchens can be, now this is not milligrams, they're not micrograms, these are milligrams. So these are very high concentrations of pollutants that women and children are exposed to on a daily basis. So it's not unusual that a kitchen looks like that at all. And so infections, chronic obstructive pulmonary disorder, and the like is caused all the time. Next slide, please. Thanks. And so I don't know if you realize, but indoor HAP, household air pollution, indoor air pollution, it causes way more deaths than outdoor air pollution worldwide. Like on the Global Burden of Disease report that came out in 2013, and it's confirmed by subsequent research, estimates that more than 4 million people die prematurely due to breathing this in their homes. And virtually all of this is in lower income countries. Virtually all of this. There's some spots in higher income countries, but it's expected that maybe 20,000 worldwide have this problem, breathing, premature death from this reason in the higher income world. It's basically a low income country problem. Next slide, please. And the fourth point, the fourth kind of reality that I want to kind of share with you is that tried to establish that forests are very important in the low and medium income country world. That's where the loss is occurring. And then another really important trend is over the last 40 years or so, a lot of those forests have been devolved to communities. That communities or even households are managing them. In China, very interesting program because of course the community level was the default under communism, and then so their policy shift was to move control of forests to households, actually. So even taking it a level lower. But a lot of the trend around the world is to go from central governments to communities. And now those collective forests are about 30% of the low and medium income world. And so these forests are providing all sorts of services for these people that we often think of. In Nepal, which I'm going to be talking a lot about, I would say that farmers now view forests, their main function, as recharging underground aquifers, actually. That's their main function when I talk to farmers there. But they also do air pollution filtration, erosion control, and researchers at Portland, here at Portland State, have really highlighted the importance of air pollution filtration, especially Forest Park, to help knock down some of those air pollutants before they get to people's lungs. And importantly, we've got all these, I guess trend number 3 or so was that so many people are burning biomass fuels, and so these are the forests that provide those to those people, these collectively managed forests, providing fuel wood, but also fodder and grazing, because in a lot of these countries, there are low penetration of banking services, and so people save by buying animals. They buy animals, and then but unlike a bank account, you don't have to feed it. Animals you need to feed, and so a lot of that wherewithal to feed those animals comes from these forests. So grazing and fodder collection. And so I want to emphasize that these low and medium income countries, these are not the countries that cause climate change, right? The US footprint over the long period of which we changed the climate is the US has the biggest footprint. But low income countries have all taken on obligations under the Paris Agreement, signed in December, agreed in December 2015. So you can go on the UN Framework Convention on Climate Change website. You can see what their obligations are. You can see those concretely and see what they're in for. And most of those, if you look, most of them have seen opportunities to enhance their forest, meet obligations, and grow in a greener way. If you scroll through the low and medium income countries, you'll see that coming out. And more often than not, they say, well, we're willing to do this, but we need some finance for that. So I'm going to talk a little bit about Ethiopia, mostly about Nepal. So what is Ethiopia's Paris Agreement commitment? Well, I just grabbed this from it. They say that they're going to limit their greenhouse gas emissions to 145 metric tons. US is about 5,500 metric tons. So Ethiopia is very small in the world, on the world stage. Nepal is like 0.02% of world emissions, to give you some scale. But they're going to reduce those by 64% compared with their business as usual scenario. And there in that graph, we're like, where are they going to get it? Okay, they're going to start up here, and most of it is forestry. Most of that is forestry. That's where, and that's really typical of lower countries. They said, well, Ethiopia is down from 40% forest cover to 6% forest cover. This is an opportunity for us to do a bit better and meet our international obligations as well. So it's a win-win. It's a win-win because, of course, as we talked about, forest provides so many ecosystem services, not just climate change. That's not what this is about. And interestingly, of that forestry piece, a fair chunk of that, I would say 25% of it, is improved biomass cook stoves to use less wood and reduce smoke in the house. That's a really important tool in the Ethiopia nationally determined contribution. And in Nepal, same thing. Nepal has, as I'll talk about, Nepal has a world famous community forestry program, and their strategy is to maintain at least 40% of total area of the country under forests. So that's a pretty good percentage in Nepal. Further promotes afforestation in public and private lands, environment-friendly infrastructure development, and the conservation of biodiversity. Very typical, not surprising because these countries are not heavily industrialized, so that's not their go-to for reducing carbon emissions. So the areas that I'm going to talk about are forest collective action, and so in my work, I've done work on this in Nepal, Bolivia, and Ethiopia. And why would they do this? Well, there's a long history of theory on this to try to get better buy-in, to get people's incentives aligned with the social interest, and furthermore, just to allow opportunities to better organize forest access and also investments in forests, because of course you can invest in forests as well. And then secondly, just have a little bit to say about the promotion of these improved biomass cook stoves. Most of that work is in Ethiopia, and Sahan has been integral to that work, and a little bit as well in Nepal. And the purpose there is to more efficiently burn the fuel wood to reduce smoke and also use less fuel wood, reduce the burdens on households, reduce the greenhouse gas emissions, and so forth. And I would like to emphasize that these are viewed as bridge technologies because we need to move away from these biomass fuels. They're too hazardous, they're too much work for people, but that requires infrastructure and major investments, and that takes time. And so as I tried to emphasize to you, probably a lot of the world's going to be reliant on biomass for a while. And so some of that, I'd like to link with collaborators, like to link the work to international initiatives, things that I think kind of matter. And so the UN Sustainable Development Goals, I think, is something that I've had my eye on since it was passed. And so, I think the work, has some contribution on climate action, definitely the life on land, SDG 13, equities. We can't leave we can't save the planet at the expense of these particular people that are very low, often very low income. So inequalities, reduced inequalities is key. And then good health and well-being because of this, especially because of this respiratory issue associated with this stuff. So one of the key findings of the work is that compared with open access, so open access meaning just free, take what you want. Collective action, forced collective action, it can increase carbon sequestration, that's for sure. But it really matters how it's measured. It matters how it's measured. In Nepal, we find some evidence of, yes, it matters. Ethiopia, we don't find evidence. Some discussion that maybe this focus on carbon in forest could have consequences for biodiversity. Are there trade-offs there? We find not in Nepal. We did I'll try to show you a little bit about the deep dive we did, and we don't find that. We find that forests that have higher carbon, they also have more biodiversity, at least in terms of trees. We didn't look at animals. They can also be more equitable, and this is another area in the literature where there was some controversy because perhaps these collective systems, the elites just capture that and take them over, and we don't find that in Nepal. We don't find that happen. And then if we think about it, there could be linkages between these common forests and what goes on the farm, and I think there is. And one of the areas of linkage perhaps is that as those common forests get better managed, people plant trees on their own farms to compensate. And we find that's occurring strongly. I haven't analyzed it in Nepal, but I suspect that's there as well. But definitely in Ethiopia and Bolivia, we find that when these common forests get better managed, people plant them on their own farm. So this is the stove that Sahan and I and others have analyzed. It's called the Mert stove. Mert means best in Amharic, which is one of the languages of Ethiopia, and it's for cooking the injera. You've had Ethiopian food, I hope, right? Yeah. Okay. So you know that the heart of that is the pancake, and so that's how injeras. That's the Mert stove. If there's no Mert stove, they would do it on a 3-stone fire. But what the plate there is it's not a pan. It's actually made of clay. So so injera is not fried. It's baked. It's baked. And so this is the Mert stove. So it controls the fire, and you can also cook something on the back as it comes out. It doesn't have a chimney yet. They're developing a version that has a chimney. So we looked at this because this is the stove that the Ethiopian government, this is a key part of the Ethiopian government's program and to fulfill its commitments on climate change, this Mert stove. And so we did a really big look at this, and we found a few things. First is that people regularly use them. That's a big issue in improved stove promotion, that people say, oh yes, thank you, very polite, thank you, oh, very happy to have this, and then it goes in the corner and they don't use it. But we don't find that. We used electronic monitoring over 3.5 years, and they use them. So that's huge. Furthermore, and this is in a paper that's co-authored with Sahan and led by his former colleague at Colby College, Dan Lefebvre, we find that these Mert stove have health benefits for kids. Like kids who were really little, that first 1,000 days when they had the Mert stove, when they got beyond that, compared with those who did not have these stoves, they were a little bit taller. And so with Dan's leadership, field colleagues, Ethiopian colleagues' work actually measured these kids. We find out that these stoves, they reduce fuel wood use. And that's not absolutely obvious, because there's a lot of things that could happen. You know, there's the do the people use them piece, and then are they really more efficient? So putting those together, as we did, we have a paper coming out in the journal Ecological Economics, we find that it does reduce wood. Not an enormous amount, not as much as the promoters predicted, but it's significant by a quarter for sure. And you know, the folks in rural areas of Ethiopia are busy, especially women, a lot on their plates. And so to have a technology that's more efficient, that then just takes a lot of time and trouble to use, it's just a non-starter. It's just a non-starter. So that was another thing we wanted to look at, is what about the cooking time? Does it take longer to use, or does it save women, particularly women, a bit of time? And we find that it does save a little bit of time. And so it doesn't take longer to cook, it takes a little bit less. And importantly, we find that users are satisfied with their mud stoves. You know, while ago, I did work on this in Nepal, and South Asia is tough for promoting these stoves, because the cuisine is very, very varied, unlike in Ethiopia, where this is about injera. But in South Asia, it's much more varied in terms of the stoves. And so it's been difficult to get satisfaction, to get people really liking the stoves. But it seems like we have a bit of a better chance in Africa. Other evidence, Senegal, Rwanda, seems to indicate that people like the stoves that are promoted there. So it's a little bit different, South Asia versus Sub-Saharan Africa. And then we have some other papers that are on this. So mostly what I want to talk about today is about Nepal. I would focus on that. I gave a talk on the stove side in conjunction with Sahan last year or the year before. And so I want to focus on a bit more on the forestry side. So here's Nepal. It's right there between India and China, just sandwiched right in between. And it's, of course, got high mountains, famous for that. In the far corner there to the right, it would be Mount Everest. The white part there is the high Himalayas. The blue is what they call the middle hills. About half the people in Nepal live in the middle hills. And then the green part is called the Tarai. And that's an extension of the Indian Gangetic Plain. And so that's a plains area. It's just in this last World Development Report, and I'm really pleased to report this, is Nepal, after forever being classified by the World Bank as a low-income country, is now a lower medium-income country. And that's just huge. You see that this low-income chunk, which used to be enormous in the 2000s, 1990s, it's just shrinking. And so Nepal's a part of that, which is just, it's just great. So Nepal is famous for many things, but one of them is the Nepal Community Forestry Program. This started in the 1970s, 1980s. If you go back and read the literature then, there was major talk about complete deforestation of Nepal and what was going to happen in India, what was going to happen to the rivers that go down to Bangladesh from these Himalayan mountains. And there was real concern that there would just be widespread flooding as Nepal completely deforested. Well, so as a result of that, they created this Nepal Community Forestry Program, which was enacted in law in 1993. And now, as of today, there's about 20,000 community forest user groups that manage their forests themselves with regulations and really in collaboration with the central government. And now it's basically all of the hills are under this system, and it's about a third of the total area. But the hills are really the important part. Because of those slopes. And that's where the community forestry program really is. And so we asked a few research questions. The first is, does this Nepal community forestry program sequester more or maybe less carbon than the government forests? And that's related to the climate sustainable development goal. Do community forests have better or worse tree biodiversity compared with government forests? So that's the life on land. SDG, are CF communities more or less equitable and fair than the government forest communities in terms of benefit sharing? And then kind of underpinning all of this, is the management better? Is the management of the forest better or not? And so, part of the reason I was interested in this with others is because there just wasn't that much literature that actually just tried to get to the heart of the matter and try to answer these questions rigorously. And so this is the kind of the introductory article from a special issue of World Development that I co-edited with a friend, Alan Blackman, who's at the Inter-American Development Bank. And so we pulled together a bunch of research on this using what's called experimental or quasi-experimental methods that tried to rigorously analyze these types of things. Like, what are these devolution policies actually doing? So the summary of the results here, just to make sure that we get to them, to give you the punchlines here. The carbon benefits we find comes from the collective action that you don't need like an official government stamped program to get these carbon benefits. And the benefits, the real danger, and those of you who've taken environmental economics classes, students, you've heard this a million times from me, that open access is the enemy of land-based natural resources, right? Have you heard that from me? Yes. So that's the thing that we found, is that it's really are the communities organized or not? That's important, not the government stamp. We find, and I think this is a very important result as the world moves towards relying on forests to sequester carbon, that there may be trade-offs, but at least in Nepal, with that type of program, we do not find trade-offs. We find that more carbon and biodiversity go together. And I think that really is a source of relief, I think, for us. And we don't find that this program is somehow elite captured. People like that, and especially indigenous groups, women-headed households, these are the big cheerleaders for this program, the traditionally marginalized groups. And these results are really underpinned by what we find as more effective management. So what do we do? This is the data that we gathered. We went across the country, looked at 130 forests, 65 of them in the program, 65 outside the program, half in the Terai, half in the hills. And there's just less penetration of this program in the Terai, so our sample reflected that. And so we built off an existing nationally representative sample that the government collected and matched non-community forests to those community forests. And then we did a 1,300 household sample, 10 in each of those 130 communities. So here's where the sites are. So you see they're pretty well spread across. They're not in the high Himalayas because there's not really forest there. So it's all in the middle hills and the Terai, and the red is the government forest, the green is the community forest, triangles are the hills, and squares are the Terai. So it's pretty much, it's a naturally representative sample. Did surveys in a couple of ways, community surveys and a variety to better understand like how these communities manage these forests, like how does this actually work? And then at the household level, to better, to know about their characteristics, ethnicity, caste is important in Nepal still, gender, and their perception, their well-being, their assets, and their perception of the forest management. And then we went out in the actual forest and we drew a bunch of circles. And so standard forestry practices, I partnered with foresters to kind of use standard forestry practices to measure these things, and so to go out there in the field. And so the key issue here the key empirical issue is to just make sure that when we say there's effects, there are really effects. And so you might have so each of these shapes kind of represents like a different type of household or community. So you've got the oval types, you've got the triangle types, you've got the rectangle types. And the key thing we want to compare like and like. So we want to compare the brown ovals to the brown ovals, blue ovals to blue ovals, and so forth. And the ones that don't have any counterpart in the community forestry program, we want to leave those out. We leave those out. Compare like and like. That's the challenge. And so what we do is we used a panel data regression, and the panel is at the plot level in the forest for the forest analysis. And then the other part is propensity score genetic matching with replacement. That's one of the quasi-experimental methods that I mentioned. And tries to assure that we're comparing things that are similar by actually only comparing matched observations. What we were really surprised to learn, because this program is really famous, this community forestry program, is that there's a lot of collective action type behavior outside this program. And this is something I've suspected for a long time, working in a number of countries on this, but it was really interesting to document it. And so here's what we found. So those are community forests, non-community forests, and these are carbon in tons per hectare. Just looking at the raw data, we see that the non-community forests actually have more carbon than the community forests. That doesn't take into account, so I mentioned comparing like and like, and one of the things that's critical in that comparison is the ecological zone. And so the Tarai is a much more productive ecosystem than the hills. And so we see that that's mostly driven by the Tarai, because the Tarai has more. And I mentioned that the Tarai does not have as much community forestry program penetration. So this is just one dimension of why we need to kind of disentangle things to get to the bottom of it, if we can. And so here's the regression results. You remember that the carbon is about 95 tons per hectare, 95 tons per hectare. And so these are the results of the community forestry program, whether the respondent, the leader, could identify the group formation year and potential indicator of forest collective action, or both. And we used a variety of environmental controls, including satellite imaging, the 1990 baseline measure of greenness, NDVI, and a variety of community controls. And we find that the community forestry program, so those stars indicate how sure we are of the estimates. So we see a positive estimate there, but it's pretty small and not insignificant. So we cannot reject the hypothesis that community forestry does not increase carbon. We can't say that it does. But if we look at other measures of collective action, we see some more juice to it. And especially when we use our broadest measure, notice that if it's one of those two, or a proposed member somewhere in that group has some aspect of collective action, basically we're increasing the carbon by about a third, because it's the average is 90 to 95, right? So big effects, big empirical effects, and the 3 stars means we're 99% sure that estimate is not zero. 99% sure. So the findings on this piece is that collective action outside the community forestry program is important. And something that's part of this paper that I didn't mention is that that these forests are probably, it's not just a matter of the carbon or the biodiversity, which I don't think I'll probably get to, but they're higher quality by other measures. Like there's more trees per unit of area in the community forestry program. Forests and seedling regeneration. That was where the small circles came in, is our field folks, they actually counted the number of seedlings there. And in the community forestry forests, there's more seedlings. So by a couple of measures, these are sort of better forests. Anyway, so I'll stop there, I think.